quadratic, here we got to find a whole bunch of things, right? We got to find the vertex, got to find the axis of symmetry, got to find the x-intercepts, got to find the y-intercepts. Is this thing facing up or down? Yeah, it is facing down because of that negative there, right? Okay, so already we've got some of these questions answered. All right, so do you guys remember the formula to find the axis of symmetry here? Over negative b over 2a. So opposite of b is negative 4 over 2 times negative 1 is negative 2 or positive 2. That means my vertex has 2 comma something, right? I can draw my axis of symmetry in here. I probably ought to get in the habit of writing x equals 2 there. But now for my vertex, how do I find my y value? Plug in the 2. So really it's f of 2 equals negative 2 squared plus 4 times 2 plus 1. 4 4 plus 8 plus 1 equals 5. Okay, I've got my vertex now at 2, 5. That's up here. We know it's facing down. My a value, if you remember, was negative 1. So if I go down 1 over 1, remember it's always over 1, no matter what that number is. 2 quick points. Y-intercept's pretty easy now, right? If to find the y-intercept, we know that the y-intercept is right here on the y-axis. What's my x value? Someone said it out, said it, they just don't want to say it loud. So f of 0 is equal to 0 plus 0 plus 1. Is that going to work out that way every time? In standard form, yes. Okay, so my y-intercept is 1. So look what happens here, you guys. Not only do I get that point, but I get a bonus point over here. It's symmetrical. Okay? Last thing we got to do, we got to figure out where these things cross the x-axis. I can try to factor, and you guys are looking at that going, yeah, that's not going to work, is it? I could complete the square, or I could use the quadratic formula. Any opinions? I've never known high schoolers not to have an opinion. Quadratic formula, finally. See, I knew somebody would. Gotta love you, Brooklyn. Okay, so let's do this so I get more room. Quadratic formula says x is equal to the opposite of b, negative 4, plus or minus the square root of 16 minus 4 times a, which is negative 1, times c, which is 1, all over 2a, which is negative 2. Ooh, okay. So we know that this right here is just going to be plus 4 or square root of 20. Negative 4 plus or minus the square root of 20 over negative 2. Running out of room. Let's take it up here. Negative 4 plus or minus 2 root 5 over negative 2. And this is where we get you, right? The negative 2 is going to come out of both terms. So when the negative 2 cancels, this becomes positive 2. This becomes negative positive. The positive negative goes negative positive, but that's irrelevant, isn't it? Right here, right? When you divide 2 by negative, or plus or minus 2 by negative 2, doesn't it become negative 2 positive 2? Which, again, is irrelevant. So it's still plus or minus 1, right? Let's rewrite that as 2 plus or minus root 5. Could we estimate this? Because I don't know where that is on the graph. This is 2 plus or minus square root of 5. How big is the square root of 5? How, how big is the square root of 4? 2. How much bigger is the square root of 5? Oh, plug it into the calculator. That's cheating. What is it? About, it's not very close to 9, right? Square root of 9 is 3. So it's closer to 2 than it is to 3. So 2.2-ish. And doesn't matter. Remember, we're trying to estimate, right? So 2 plus 2.2 is going to be 4.2. And 2 minus 2.2 is negative 0.2. Ooh, let's plot those. Negative 0.2 is going to go right there. 4.2 is going to go right there. Nice smooth curves. And we're done.